Hi! In this video, we will talk about charged particles in circular orbits. In the previous section, we've seen the moving charges in the magnetic field. The force of the magnetic field on a moving charged particle is at right angles to the direction of motion of the particle. Since the magnetic force is perpendicular to the direction of travel, a charged particle follows a curved path in a magnetic field, and the particle continues to follow this curved path until it forms a circle. The force causes a centripetal acceleration because it is perpendicular to the velocity. Now the radius r of the circular orbit depends on the speed v of the particles and the magnetic flux density b. At any point on the orbit, the particle is acted on by a magnetic force. F is equal to bqv, and the centripetal acceleration is a equals v squared over r, and it is towards the center of the circle. So if we apply Newton's second law, which is F equals ma, what do we get? bqv is equal to mv squared over r. So if we rearrange the equation to get r, then r is equal to mv over bq. What does this equation reveal about r? R decreases. We mean by that the path is more curved, and that is if b is increased or v is decreased, and if particles with larger specific charge are used.